Good day, everyone. I am Anko Senamilo Afumiola. I am a postgraduate student at the Department of Chemistry, Lagos State University in Lagos State, Nigeria. And here's my presentation for the VCCA Conference 2023. I'll be presenting on the topic using Young of the Year fish to biomonitor pollution in selected aquatic environments in Lagos State. Here's an outline for my presentation. So when you see this image, what comes to mind? You literally can see a fish, but it's not just any fish. This is a young fish, and that is what we are mainly focusing on in this presentation and in this study. We are not just focusing on fish, but we are focusing on the category of young fish, which we categorize or which we call young of the year fish, and I'll be explaining more of that in detail. So what is fish? Fish is any species of vertebrate animal, that is animals that have backbones, found living in fresh salt waters and even brackish waters. It represents the class Pisces, and they are known to be cold-blooded animals, and they breathe using gills. Some types of fish that we know are salmon, lungfish, um, finfish, whale sharks, and even some species known as woody sea dragons. This kind of fish, they look like leaves, and they actually, just like chameleons, they blend with the coral reefs or the seaweeds underneath the waters to hide from predators and all. So yes, some fishes can also detect motion in water, and some can find their prey, while others navigate through the water by detecting electrical charges or sound. And here's a fact: 70% of the planet Earth is covered in water. And this is to tell you that fish has been abundant on Earth right from the beginning, right from at least from fossil records. It says for at least 500 million years. But in recent times, we understand, or we realize that fishes are diminishing in our waters. Why is this? That is the sole purpose of our study. We want to find out, okay, we've noticed or we've studied some form of pollution going on in our waters. What can be done, or what is being done exactly, and how is it affecting fish, number one, and how can fish also be used to monitor or to help us understand what is going on in the water. And so, um, when toxins are present in the system of fish, it leads to change in tissue matter. It leads to change in their behavior, whether swimming behavior, resting behavior. It leads to reproduction changes, rather. Yes, the fish, when they have metals in their body, they would cease to produce as much as they usually do. Um, and that affects definitely production for us, for humans, to even get fish to eat and all of that stuff. It also prevents growth in fish, as well as change in gender. So you might see a fish that was a male species before changing to a female species because of the presence of metals in the system. Also, which is the ultimate consequence, is death. Here's just an image of a young tilapia fish. So these ones are actually genetically modified. Yes, this is a young tilapia fish. And what do we mean by young fish? We're going to be discussing that pretty soon. So young of the year fish, as we've said at the beginning of the study in the title, is also known as juvenile fish, and it is known as the immature offspring of fish. Uh, More specifically, it is known as fish that is yet to develop or mature sexually. That is, yes, definitely, it has the reproductive organs right from when it has been, um, right from when it's developing. That is, it's just going from the larva stage, and then that stage between like larva stage to adolescence before even getting to the adult stage. So young fish is fish that is yet to develop, that is less than 6 months. That's why we call it young of the year fish. And so biomonitors, which is also a keyword in our presentation, our study, is organisms is known as organisms that provide quantitative information on the quality of the environment around it. So biomonitors are organisms that are used to um, help us understand the response to something or a situation in an environment. That is what biomonitors are. And so there are several types of biomonitors, but the biomonitors that we're going to be focusing on here is fish. And fish have been known to be very significant biomonitors in the aquatic system because of it helps us to estimate the metal pollution levels in the water system. And also fish are located at the end of the aquatic food chain, which makes it easy for accumulation, yes, and biomagnification in their systems, which later on transfers to man because we eat fish, and then leads to chronic diseases in humans, which is why so many times, like some of the diseases that we find in humans actually come from what we eat. And we eat fish, many people eat fish regularly, and when this fish inhale or eat up microplastics, for instance, or get heavy metals into their system, and when man eats it, it gets transferred into man, and it biomagnifies inside man, leading to chronic diseases and sometimes death, which is why we have so many diverse diseases at the moment, because pollution is very rampant in our waters. And so marine pollution is the contamination of surface water bodies, fresh, salty, or brackish, and it is mostly caused by land-based activities. So most of the causes of marine pollution actually comes from the land. Man activities such as plastic pollution. We are using plastic so much, and we are not even reusing or recycling as much plastics as we are using. So these things go into the water system and affects fish. Ocean acidification, definitely coming from land. Some of the chemicals that are being let out from our industries, from manufacturing, and all of that gets washed down into the oceans. Nutrient pollution, such as from agricultural lands, from pesticides, from insecticides, and all of those things. They get washed down when rains come, when floods come, washes it down into the waters, into our oceans, into our seas, and definitely causing toxicity in the water, and definitely for the fish in the water. Underwater noise, maybe from marine transportation, submarines, ships. Every single time, these things are quite abnormal for the marine life, and definitely causes disturbances in their system. Pollution from marine debris, which is also coming from land, definitely sewage, plastics, like I mentioned before, and other forms of debris are being washed off or being dumped. Because even during my study, I found some of the sites that I went to. In fact, all the sites I went to, I found out that they were being used as dump sites. So people deliberately dump their waste on the waters or at the shore, and when rains come, these things get washed into the water and affect our marine life. That's when we see that our waters need clean up, because plastics are floating on our waters. So some causes, like I mentioned, of marine pollution are plastics, oil spills, sewage which have been dumped, oil spills, deep sea mining. We're mining oil, and these things get spilled sometimes or get vandalized, and these pipes are leaking into our systems, and fish cannot survive in these systems. That is why most times they either migrate or they die, or it destabilizes their reproductive system, which in turn affects humans. Surface runoffs, such as from farms, and also algal bloom, which is caused by excess nutrients in our waters. So the problem statement of this study is that pollution, as we all know, or as many people know, is now a huge problem in the world. It's a global issue, and we are all trying to, solve these problems, especially water pollution. Because the truth is, water is life, and we all need water to survive. We need it for drinking, for eating, for cooking, for feed, for everything, to feed our animals. Without water, we can barely survive. In fact, we wouldn't survive. Most people can go without food, but cannot really go without water. If you have water for 40 days, it can still sustain you rather than going without it. If you go without food for 40 days, you can still do with water compared to if it's the reverse. Um, yes, and so millions of people are dying each year from polluted water. Cholera, so many different diseases are coming up because of polluted water, and these are caused by oil spills, by chemical pesticides, by industrial waste, by sewage and wastewater, mining activities, fossil fuels, fertilizers being washed off from farms, and these issues are causing big problems, or rather these things are causing big problems in our water systems, and the problem has gone on for way too long without us monitoring and cleaning up and bringing up implementation strategies to combat these problems. Therefore, this study seeks to it actually starts to explain how young fish can be used to monitor pollution in aquatic environments as opposed to the use of adult fish. The aim of the study is to show that young fish can be used as biomonitors for heavy metal pollution in aquatic environments. And the objectives were to collect fish samples from 3 locations: Badagry, Itumaro, and Langbasa, which are locations in Lagos State, Nigeria. Chemical analysis of fish samples via acid digestion, and the third one was to carry out statistical analysis of the data generated, that is, descriptive statistics, correlation analysis, and principal component analysis. Here's a flowchart showing my methodology for this study. Here's a map showing the sampling locations. As you can see that these locations are in water-based communities, water-focused or water-centric communities, because I had to take the fish directly from the water. So this is a brief on the study areas. Tilapia and catfish species were collected from 3 coastal communities in Lagos State: Badagry, Itumaro, which is Liverpool Market, and Langbasa. And so Badagry is a coastal town and a local government area in Lagos State, and it shares a border with the country, that is the Republic of Benin actually, and it serves as a lagoon and Atlantic port for trading between both countries. And it has a population of over 200,000 people who have a common occupation of fishing and trading. Also, Itumaro is an island in Lagos State, and it has a small population of people compared to other locations, and their occupation is also fishing and trading. Langbasa is a coastal town located close to the Lekki area in Lagos State, Nigeria, also with a small population. It is a rural environment, and activities commonly practiced are fishing and dredging of sand. The samples were collected, that is, tilapia and catfish samples were collected from the sea directly and preserved in plastic containers, still with the seawater, just to preserve them, to take them to the laboratory, where they were further stored in a refrigerator. Then they were later sun-dried for about 7 days on mesh nets, and after drying, the fish samples were placed in aluminum foil for storage in a refrigerator until I was going to perform the analysis on them. And the chemical analysis involves this process. The fish samples were cut up into tiny pieces and they were homogenized. That is, the muscle, the gills, everything were cut up together and then homogenized, like mixed together, to ensure that everything is in there and whatever I'm going to analyze is all in that sample. Um, 1 gram of the sample was weighed into a pre-washed beaker and digested with nitric acid and perchloric acid in the ratio 3 to 1 to a volume of about 3 mils, and after which I let the digest cool off and then I filtered into a 15 ml standard flask, making up to mark with distilled water. Afterwards, a flame atomic absorption spectrophotometer was used to analyze the samples for metals. And then statistical analysis was done using SPSS version 20, and I carried out descriptive analysis, correlation analysis, and principal component analysis (PCA) of the data generated. These are the quality assurance steps I took note of while I was doing my study. I used analog grade chemicals and reagents. All the solutions were also standardized. I ensured that the analytical balance was calibrated and also carried out equation of analysis and blank analysis. Here's my results. The descriptive analysis showed the minimum amount, the maximum amount amongst the three locations for each of the metals, and I compared my values with the WHO limits. For lead, that's the WHO limit. But I noticed, or I realized from my results, that nickel, zinc, potassium, sodium, and calcium had higher values compared to the WHO limits, which is in milligram per kg. So um, yes, nickel had a higher value of 57.17 milligram per kg compared to 14.83, which has been stated by WHO, as well as zinc 494.33 compared to 288.2, potassium at 7,387.5 compared to 3,000, sodium 6,500 compared to 3,000, calcium 10,789 milligram per kg compared to 5,000. For the correlation analysis, I detected that iron, some of the parameters uh, correlated or had strong correlations, had strong interrelations with some other metals, such as iron having strong correlation with lead at 0.855 rather, potassium also with lead at 0.822, calcium as well with lead at 0.899. We had some others like iron with cadmium, iron, copper, and zinc, and some others correlating strongly with cadmium. And this is to tell us that this is possibly coming from the same source. For instance, maybe the same source of pollution that's coming in, probably through oil spills or through mining or through debris. They are both coming from the same source in these locations. So this is why they are strongly correlating with themselves. For the principal component analysis, this breaks down the results and the data and the parameters into variables, putting them into types. And so it shows which ones are strongly contributing to a particular type, to a particular category. For instance, lead, cadmium, iron, they both okay, from this results we had two principal components. That is, the results were categorized into two principal components, gave us two principal components, and in principal components one we had lead, cadmium, iron, potassium, and calcium. So this is telling us that these are the metals contributing strongly and significantly to this particular category, also possibly coming from the same source. Nickel, uh, zinc, and sodium were the stronger contributors in principal component 2, also telling us that they're possibly coming from the same source. And so 9 metals were analyzed from these fish samples, that is tilapia and catfish samples, collected from Badagry, Tumaro, which is in Liverpool Market at Apapa, and Langbasa, which is located at the Aja axis. And from the descriptive statistics, lead, cadmium, iron, and copper were found to be within the WHO permissible limits, while nickel, zinc, potassium, sodium, and calcium were above the WHO permissible limits, which is quite disturbing. An excess of nickel and zinc causes toxicity in fish, and it weakens the immune system, therefore leaving the fish up to diseases and possibly death. It causes tissue and organ damage, growth defects, and also reduces reproductive ability. Therefore, the fish would not even be able to grow, whether reproductively, and will not be able to fertilize egg, that is for the female, and will not be able to produce young fish for continuity of life. High potassium levels in fish leads to slower swimming, increased resting, definitely affecting the energy metabolism of the fish. Excess sodium in fish leads to dehydration. This is when the fish will start coming up for air or for oxygen outside of the water, because the water is already saturated with salt, and the fish is definitely dehydrated. And also it ultimately leads to death. An excess of calcium in fish leads to lethargy, that is tiredness all the time, erratic swimming, slower growth, and even death. Here's my conclusion. Adult fish has been used in previous years to analyze for heavy metals. This study shows that young fish can be effectively used to monitor pollution, as they are prominent in oceans and seas and show early signs of contaminants in their system. So this study shows that even though adult fish can tell us can definitely tell us that, okay, there's something going on in this water system, it is better, or would I say preferable, to use young fish, because they, just like babies, human babies, they can hardly keep these things into their systems without showing early signs. When a baby has infection or is feeling something, it tells that it indicates, or it gives off this telling signs that something is going on in my system and I can't deal with this. So when fish, when they have these toxins in their system, they can't deal with it, and it's either they die or they lose themselves, or definitely they migrate, but they are still really quite young. So the easiest thing, in fact, the greatest consequence, or the quickest consequence, is that they die, compared to adult fish, just like adult humans, who has adapted to the system and can keep in things, or can keep in diseases without even knowing for years, because of the adaptation system, or adaptation abilities that human has. So compared to adult fish, young fish can easily tell us, or easily act as biomonitors to give us responses that something is wrong with the system and that we need to fix it. There is a high measure of metal and nutrient pollution in the surface water bodies that were studied, which leads to migration and death of fish. Yes, when I was undergoing my study, because I had to cross the waters, each of the islands, to, in canoes, in boats, to get fish, and fishermen were very helpful, and getting to those islands and being in those boats trying to catch the fish, it was very clear that fishes in our waters are diminishing, because even the small scale farmers, of small scale fishermen, they can barely find fish to sustain their families. The waters have been so polluted that the only way we can really get fish now in abundance is through fish farming, getting them from ponds rather, which is quite disheartening, because many people or many of the small scale farmers, many of the small scale fishermen don't really have the capital to start up a pond, and they rely um, on the fish that's coming directly from the water. And when they don't have this, because the fish are either dying, or they are not producing, or they are migrating, they can barely feed their families, and even sell off some to be able to fund some other things that are essential in their life. And so it also definitely affects the revenue generated in the economy. The government will not be able to generate revenue from that particular sector of the country. Therefore, my recommendation is that periodic monitoring should be done by government agencies on all seas and oceans in Lagos State, Nigeria. Also, we should have environmental police, which will keep a check on industries and farms and every other major point or source of pollution, marine pollution, that we've identified, to ensure that they are keeping up with the standards and they are not dumping waste indiscriminately in our systems. Also, sensitization programs should be held, awareness programs for residents, to let them know that dumping of their waste or treating our oceans and seas as their dump sites definitely um, brings back a consequence on them, and they all have a role, we all have a role to play in cleaning up our systems and ensuring that marine life is secured and that we are sustainably living in our world. And so here are my references. Here are my acknowledgements. I really want to thank my supervisor, Dr. Majalagbe AO, is an associate professor in the Department of Chemistry, Lagos State University, and also Dr. Onwadi CT. She's an associate professor as well at the Department of Chemistry, Lagos State University. My HOD, Prof. Olowu RA, Department of Chemistry, Lagos State University as well. Also, the host of the VCCA conference, Professor Ponadurai Ramasamy, and the entire Faculty of Science, University of Mauritius. Thank you so much for this opportunity. All the academic and non-academic staff of the Department of Chemistry, Lagos State University, and as well, my friends, thank you all for the support. Thank you for the opportunity. Thank you for everything. Thank you.